Hello friends, I am from Chemistry faculty of QLS Academy. Carbon compounds undergo different types of chemical reactions like combustion, substitution, addition. So, in today's session, we are going to learn about chemical properties of carbon compounds. Hope you will enjoy today's lesson. Now let's get started with our today's lesson. Daily, we use a variety of substances, but the most important thing is fuel. Fuel drives all the machineries which manufacture the items we use. Fuel is also essential for the working of our own body. The food we eat is the fuel for our body. Most of the fuels are carbon based like coal, wood, petroleum, methane, etc. These fuels are called as fossil fuels, means they are formed by the remains of dead plants and animals of previous eras. Coal is formed of remains of ancient plants and animals pressed beneath the layers of soil and rock. With time, they slowly decomposed into coal. Petroleum is formed by remains of plants and animals that lived in sea. The remains of the dead plants and animals of sea sank to the seabed and got covered by silt. Under the high pressure, those remains were decomposed by bacteria, turning them into oil and gas which we are using today. These fossil fuels are not infinite. इनको हम बेहिसाब यूज़ नहीं कर सकते, कभी ना कभी ख़त्म ज़रूर होंगे. They will exhaust pretty soon. So, we should be considerate towards misusing them. So, since most of the fuels we use are carbon based, we will first discuss about combustion. All compounds of carbon react with oxygen to produce heat and light along with carbon dioxide and water. This reaction of carbon with oxygen is called as combustion. सारे carbon compounds, most of the carbon compounds कह सकते हैं, जब react करते हैं oxygen के साथ, they produce heat and light along with carbon dioxide gas and water. Combustion is a type of oxidation reaction. While burning, most carbon compounds also releases a large amount of heat and light. This heat and light is the main purpose for burning any fuel. हम कोई भी fuel जलाते हैं तो हमारा main purpose क्या होता है? उसमें से heat, उसमें से energy को extract करना, और energy हम किस form में extract करते हैं? In the form of heat or light. For example, when methane, a major component of biogas, is burned, it produces carbon dioxide gas, water along with a good amount of heat and light. You may have noticed that a candle and LPG when burned produces flame, but coal and wood burns without any flame. Coal and wood just glows red and gives out heat without any flame. Though initially wood gives out flame, जब हम wood को पहले जलाते हैं या coal को भी पहले जलाते हैं तो उनमें से flame निकलती है. But a flame is produced only when a gaseous substance is undergoing combustion. जब कोई gaseous substance को हम combustion करते हैं, सिर्फ तभी flame produce होती है. The atoms of the gaseous substance when get heated starts glowing and produces flame. But you may have noticed that wood and coal when ignited produces flame. It is because at high temperatures the volatile substances present in them vaporizes and burn with a flame. Wood और coal में जितने भी vaporizable substances, जो भी volatile substances है वो vaporize हो जाते हैं. उनको जब हम ignite करते हैं, उनको जब जलाना start करते हैं, तो उनमें से जितने भी volatile substances हैं वो vaporize हो जाते हैं और flame produce करते हैं. But after the volatile substances have vanished, they produces no flame. कोई flame produce नहीं होता है, they just glow red and radiates heat. Each substance burning with a flame first gets converted into vaporized form, then reacts with oxygen to give out heat and flame. If you have ever noticed, the flame produced by a candle and a flame produced by LPG are both different. Candle burns with a yellow flame while LPG burns with a blue flame. Actually, every element has its own characteristic flame. This can be used to detect an element. कोई भी element होता है, उसका एक अपना characteristic flame होता है. जैसे कि जब हम पोटेशियम को इग्नाइट करते हैं, it produces light purple flame. Similarly, strontium produces a reddish flame, and sodium produces a orange flame, and copper produces a greenish flame. There is also a difference between the flame produced by saturated compounds and unsaturated compounds. Carbon के compounds के दो main classes हैं, saturated and unsaturated. So, saturated compounds में जो flame produce होगा और unsaturated compounds से जो flame produce होगा, both will be different. Saturated compounds generally give out clean flame, while unsaturated compounds give out yellow flame along with a black smoke. The black smoke produced by unsaturated compounds is called as soot. Soot is nothing but unburnt carbon particles. Soot is formed because of incomplete combustion of the hydrocarbons. आपने कभी शायद ऑब्जर्व किया हो कुकिंग वेसल्स में कभी कभी आउटर सरफेस में, लोअर आउटर सरफेस में ब्लैक डिपॉजिशन आ जाता है. दिस ब्लैक डिपॉजिशन इज सूट प्रोड्यूस्ड बाय LPG. Yes, LPG. LPG, though is a saturated hydrocarbon, can produce soot. Even saturated hydrocarbons can also produce a sooty flame when burned in limited air supply. Limited air supply means less amount of oxygen, means the fuel won't be able to go under complete combustion, and hence due to incomplete combustion, sooty flame will be produced from a saturated fuel. And that's why cooking stoves have small air vents to supply the fuels like gas or kerosene with oxygen-rich environment. Combustion is one type of oxidation reaction shown by carbon compounds. Other carbon compounds like alcohols undergo oxidation in presence of oxidizing agents like alkaline potassium permanganate or acidified potassium dichromate to form carboxylic acids. कुछ कार्बन कंपाउंड्स जैसे कि अल्कोहल ऑक्सीडाइजिंग एजेंट्स के प्रेजेंस में ऑक्सीडाइज होकर कार्बोक्सिलिक एसिड्स प्रोड्यूस करते हैं. Like when ethanol is heated with alkaline potassium permanganate or acidified potassium dichromate, it oxidizes to carboxylic acid, that is ethanoic acid. When ethanol is heated with either of the oxidizing agents, it first oxidizes to aldehyde ethanol, which is commonly known as acetaldehyde. So ethanol इथेनोइक एसिड में तो कन्वर्ट होगा बट बीच में वो इथेनॉल भी बनेगा. मीन्स अल्कोहल first oxidizes to an aldehyde, then it converts into carboxylic acid. So acetaldehyde on further oxidation oxidizes to carboxylic acid, ethanoic acid, which we commonly known as acetic acid. The next type of reaction shown by carbon compounds is addition reaction. It is the unsaturated hydrocarbons which show addition reactions. Unsaturated hydrocarbons में कार्बन कार्बन के बीच में डबल या ट्रिपल बॉन्ड फॉर्म होता है. So there is a scope for more hydrogen to be added in the molecule. डबल एंड ट्रिपल बॉन्ड्स इसलिए फॉर्म हो रहे थे क्योंकि कार्बन के पास अपनी वैलेंसी कंप्लीट करने के लिए कोई और ऑप्शन नहीं था, कोई और हाइड्रोजन एटम या कोई भी और एटम प्रेजेंट नहीं थे. So the carbon atoms bonded with each other to complete their unfulfilled valencies. But when more oxygen atoms are available, these double and triple bonds can be broken to establish new bonds with newly introduced hydrogen atoms. Hydrogen is added in the presence of catalysts such as palladium or nickel. Here you can see that hydrogenation of ethene is taking place in presence of palladium. The double bond between the carbon atoms is getting broken and are replaced by two hydrogen atoms. Now, what are catalysts? हमने अभी देखा कि ये reaction, addition reaction catalyst के presence में complete होती है. But what are catalysts? Catalysts are the substances which increases the rate of reaction in a particular direction without itself being getting involved in the actual reaction. Catalyst किसी भी reaction को एक particular direction में proceed करते हैं, उसको उस direction में push करते हैं, but खुद कभी भी उस reaction में involved नहीं होते हैं. जैसे कोई भी reaction है उसमें reactant react करते हैं and product form करते हैं, but catalyst कभी भी react नहीं करेगा, वो सिर्फ उस reaction को facilitate करेगा. So the reaction which we saw here today is known as hydrogenation, the addition of hydrogen to an unsaturated hydrocarbon. Hydrogenation is commonly used to convert vegetable oils into hydrogenated oils. These hydrogenated oils are solid at room temperature and are widely used for preparation of fast food items like cookies. Vegetable oils generally have a long unsaturated carbon chains which are converted into saturated chains by hydrogenation. Hydrogenation can be complete or partial. Hydrogenation पूरा भी complete भी कर सकते हैं या फिर partial hydrogenation भी कर सकते हैं. Complete hydrogenation converts oil into a complete solid form, while partial hydrogenation give oil a semi-solid structure like margarine. Hydrogenated oils contain trans fat which are harmful for our body, so we should try to avoid food items containing hydrogenated oils. Trans fat helps in cholesterol buildup. It lowers the level of good cholesterol which are actually required by our body and increases the level of bad cholesterol. So next time you go for grocery shopping, check the labels of food items for fat content. We should prefer unsaturated vegetable oils over saturated fats like hydrogenated oils and animal fats. Unsaturated hydrocarbons undergo addition reaction because they have the scope to welcome more atoms in the same molecule. But This same do not happen with alkenes. Instead, alkanes show substitution reaction. Alkanes सैचुरेटेड हाइड्रोकार्बन्स होते हैं, सो इनमें कोई स्कोप नहीं होता कि हम और मॉलिक्यूल्स ऐड कर सकें. सो इंस्टेड ऑफ एडिशन रिएक्शन दे गो फॉर सब्स्टिट्यूशन रिएक्शन. One or more hydrogen atoms from alkanes can be substituted by other atoms. If you remember, alkanes are quite stable and do not react under normal conditions. However, in the presence of sunlight, chlorine can be added to alkanes. This reaction is quite fast. Chlorine atoms replace the hydrogen atoms one by one. So, अगर हम एक नॉर्मल कंपाउंड लेते हैं, सबसे सिंपल कंपाउंड लेते हैं मीथेन, हम उसमें अगर क्लोरीन ऐड करना चाहते हैं इन प्रेजेंस ऑफ सनलाइट, इट विल फर्स्ट फ्रॉम क्लोरोमीथेन. ओनली one hydrogen atom will be replaced by one chlorine atom. Similarly, if we add more chlorine to chloromethane, it will get converted into dichloromethane. And then if we try to add more chlorine, the dichloromethane will get converted into dichloromethane and finally to tetrachloromethane. This is the trichloromethane which we commonly known as chloroform. So, for now, this was all for the chemical properties of carbon compounds. Today we learned about different types of flames, flameless fires, addition and substitution reactions in unsaturated and saturated compounds. We also learned about hydrogenation and why we should avoid hydrogenated fats. In next class, we'll talk about some important carbon compounds which are useful in our day-to-day life. Hope you have enjoyed today's class. If you have any doubt, you can visit the following link.